Welcome viewers, in this video we will see the details about JK flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic JK flip-flop. We know that flip-flop is the storage element. It will store 1 bit of data. The previous title is the SR flip-flop, set reset. That videos are available separately. So the improved version of SR is the JK flip-flop. Now we'll see the detail. The uncertainty in the state of an SR flip-flop when S equal to R equal to 1 can be eliminated by converting into JK flip-flop. In SR flip-flop, both S and R, the S value and R value is 1, that is not defined. It is uncertain. The output is not defined. So that can be eliminated in the JK flip-flop. How it is eliminated, how the modification in the circuit is, the data inputs are J and K, which are and means AND gate with Q and Q bar respectively. That is K and Q is connected in AND gate. Sorry, J and Q is connected in AND gate. K and Q bar is connected in AND gate. That output is given as a S. S equal to J into Q bar and R equal to K into Q. Now we'll see the diagram. At the time we are able to understand. So the simple thing is J and K is connected in AND gate with Q and Q bar. So that SR flip-flop is converted into JK flip-flop. Now we'll go to the logic diagram. So this is a SR flip-flop. The S input, R input and clock pulse, the output Q and complement of the output Q. This SR flip-flop is converted into JK flip-flop by having two AND gates. In first AND gate, one input is J, another input is Q bar. J and Q bar is connected. The output of this AND gate is the S input, J into Q bar. One more AND gate, the input is K, another input is Q, right? K into Q is the R input, right? SR flip-flop is connected with two more AND gates. The S input is J and J multiplied by Q bar. R input is K into Q. So that it will be converted into SR flip-flop converted into JK. Now we'll see the logic diagram. So there are four NAND gates available. That is the basic diagram of the SR flip-flop. Four NAND gates are there. The output of this NAND gate is connected here, and one more input to this NAND gate is Q bar. The output of this NAND gate is connected here. One more input is Q. So it is interconnected. In this we are giving S and R input, and one input is clock pulse. This S is nothing but J into Q bar. This Q bar. This R input is nothing but K into Q. One input is K, another input is Q. What we discussed earlier, right? J into Q bar, J and Q bar is given to AND gate. That output is given as a S to the one of the NAND gate. K and Q is given to the AND gate. That output is given to another NAND gate. Then these NAND gates are interconnected. Now we'll verify the one output. We will see later. Now we'll go to the truth table and excitation table. Then we will verify one of the input. I will go to the truth table. So this is the two inputs J and K. Four combinations 0 0 0 1 1 0 1 1. We know that the flip-flop, the output two stages available. Present stage, next state. Present state is Qn, next state is Qn plus 1. Because flip-flop is the storage element. So the output next stage is depends upon input as well as previous state. Normally the output is depends upon input only in combinational circuit. Here output is next stage, new stage is depends upon input as well as what is available earlier, previous state also, right? So these three will divide the next state, J, K as well as Qn, previous state. Right. So that first we have four combinations 0 0 0 1 1 0 1 1. In all the cases we have Qn equal to 0. Then we'll have Q1 equal to 1. Again we'll repeat. Right. So two variable, four combination In that, first we will keep Qn equal to 0, then same 4 combination will keep Q1 equal to 1. Previous state is 1. So what will happen? Both are 0, 0 means no change. Previous output is 0 means next output also 0. 0, 1, K mean it is called a reset. Reset means 0. Whatever may be the previous state, 0 means 0 maintain, 1 means it will be maintained to 0. So that is available. Reset 0, 1. If Q1 previous state is 1, it will reset to 0. Right? So 0, 1 means the output next state will be 0. Reset. 0 means 0 maintain, 1 means that will change to 0. Then 1, 0. 1, 0 means set. It will set means 1. Set the output means 1. Now the 0 is changed to 1. Here already 1 is there, so same thing will be maintained. Right? So 0, 1 means reset 0. 1, 0 means set 1. If both are 1, then it is toggle. It will toggle. 0 means 1, 1 means 0. Right? So very easy. Both are 0, no change. Both are 1, toggle. 0 means 1, 1 means 0. 0, 1 means reset. The output will be 0. 1, 0 means set. The output will be 1. So that is simplify is given here. 0, 0 means the next state is previous state. Both are same. No change. 1, 1 means the next state is complement of the previous state. Qn bar. 0 means 1, 1 means 0. 0, 1 means set. Reset 0. 1, 0 means set 1. Right. Now this is a simplified truth table is given. No change, reset, set, toggle. Now we'll see the excitation table. What is excitation table? The output is, from the output we need to decide the input. Present state is 0, next state is also 0 means what is the input we need to give. Present state is 0, next state is 1 means what is the input we need to give. So that is the excitation table, because we need in some cases in the while designing the circuit we need to maintain present state is 1 and next state is also 1. What is the input we need to give? Now we'll verify this. 0, 0. Present state also 0, next state also 0. Refer this truth table. So here both are 0. Any other condition there? Here also both are 0. There is no other condition, only this first and second. In that case J is 0. In both the case J is 0, but K is 0 here 1. So K may be X, may be 0, but J may be always 0. J is always 0. K may be anything X. So if you give J equal to 0, K may be 0 or 1, the same thing will be maintained. Then 0, 1. We'll check whether it changed to 0, 1 here. Changed to 0, 1. Only this case. For that, what is the input? 1, 0. 0, 1. What is the any more 0 to 1. So here also one more is there. 0, 1. Right? No, not that. 0 to. So the Qn is 0. Qn plus 1 is 0. 1. 0, 1 we have to refer. So this is 0 to 1. Only this case. Only this case is available. Any other case is there? 0, 1. 0, 1 to 1. Right. So now it is clear. 0 to 1, 0 to 1, two cases available. This is 0, this is 1, this is 0, 1. So these two combination. In that J is 1, K is 0. In the second J is 1, K is 1. So J is always 1 for both the case. J is 1. K may be 0 or 1. So it is X. Right. Qn is 0, Qn plus is 1. These two cases. Changes from 0 to 1, 0 to 1. For this, these two inputs. J is always 1, K may be X. Right. Then 1, 0. So these two cases. 1, 0. This is changed from 1 to 0. This is 1 to 0. Right. This one and this one. So for that case it is 0, 1. Here 1, 1. So K is always 1. In both the cases K is 1. J may be 0 or 1. So that's X. Then 1, 1. Where it is 1 1 is available here, 1 1, this case. Here also 1 1, right? This one and this one. Here both are 0. Here 1 0. That is k is 0 in both the cases. K is 0. J may be 0 or 1. So that is X. Right? I think you are able to understand. I will explain once again the first case. Qn equal to 0, Qn plus 1 is 0. What is the input? So first two is the same. Q1 0, Q1 plus is 1. That is these two things are available. In these two things we have to verify the input. Both J is 0 in both the case. So it is 0. But K may be 0 or 1. So it is given as X. Like that we identify all four combinations. This is called a excitation table. Right? Truth table means output. From input we are checking the output. Excitation table means by output, for the given output we are checking what is the input. Now we'll go to the logical symbol and characteristics equation. So this is the logic symbol. Earlier we discussed S and R, S R flip flop. From that we constructed JK. So this is the total JK flip flop. J and K, two inputs, clock pulse, output and complement of the output. From the excitation table Qn and JK, we can see by using K map we can identify Qn plus 1 from the truth table. This is from the truth table, right? So what is the output? Qn plus 1 equal to Qn bar J plus Qn into K bar. So this is the characteristics equation of the JK flip-flop. This K map is constructed using the truth table. By using the truth table, here Qn, one input, J and K, another two inputs. We know that Qn plus 1 depends upon previous output and two inputs. So that we are having Qn and JK, three inputs. From that we calculated next output, Qn plus 1, next state. So this is the equation. Now we'll see the clock pulse. So the clock pulse, this is called a positive edge triggered. Whenever changes from 0 to 1, the process will be executed. So this is the K value and this is the J value and K value. Right, what we discussed in the truth table. So this is reset, toggle, no change, set, toggle and toggle. Just keep on changing. It is purely based on the what we discussed in the truth table. So in this video we discussed the JK flip-flop, how it differ from SR flip-flop. The disadvantage of SR flip-flop is eliminated by JK flip-flop by connecting two AND gates. Then we discussed the truth table, excitation table, logic symbol, characteristics equation and clock pulse. Now we will see one more. We will verify one of the output with the logic diagram. Let us consider this combination. J is 1, K is 0. Present state is 0, that should be changed to 1. Right? J1, K0, the 0 should be changed to 1. Now we'll check with this logic diagram. J is 1, K is 0. The output is 0. It should be changed to 1. We have checked whether this present state 0, the next state changed to 1. For this combination J equal to 1 and K equal to 0. Right. So the J1, what is the one more output is nothing but Q bar. Q bar is 1. Q0 means Q bar is 1. So here we get 1. K equal to 0, one more input is Q. Q is a 0. So here both are 0. 0 0 means output will be 0. 1 1 means output will be 1. One more input is clock pulse. So here both are 1. Here 0 1. Right. 1 into 1 means 1. But it here NOT gate. AND gate means 1. NAND gate means 0. 0 1 means 0 in AND gate. NAND gate means 1. Right. Now we got 0 here, 1 here. Right. Now we'll see this. So this Q bar is connected here. Q bar is 1. 1 is connected. 0 into 1 means 0 in AND gate. NAND gate means it is 1. Right. See this, now 0 is converted into 1. Now apply this 1 here. Here both are 1. 1 into 1 means 1, but NAND gate means it is 0, right? You have to follow from top to bottom. So both are interconnected. We don't know how it will execute, but we have to follow certain procedure. You have to follow the top AND gate first. From change of output, that output is applied to the bottom NAND gate, right? From some 4 combination, we have to follow the top. Another 4 combination, we have to follow the bottom. First we have to find the bottom output. That output will be applied to top NAND gate, right? So from the truth table we can decide. There are 8 combinations available. 4 combination we have to consider output from the top NAND gate, then that will be applied to bottom. Or next 4 combination, it is reversed, right? So now we'll verify the output also. For j equal to 1, k equal to 0, the state changes from 0 to 1. We verified with the entire logic diagram. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.